Hi, my name is Dave Queener. This is Cumberland Model Engineering. And today, our tutorial is how to machine a steam locomotive driver with a raw casting. The castings that I get are investment castings, and so most of the junk that you might have on, say, on a sand casting isn't here. So we're almost at net shape, but not quite. We still have to do some facing. We have to turn the outside diameter of the driver center, and we also need to get rid of this little plug by which we hold the driver center. Pretty important if you're machining castings to already have a plug cast into the back side of the driver. That's what you're going to hold the thing by after you've made an initial cut. Important to keep your run out. In other words, to keep your driver centers true, where you have a hole in the center for an axle relative to the outside of the driver center. You want to make sure that everything is nice and concentric. You don't have it concentric, then you start getting wobble in your completed drivers. One thing you want to do is be sure that your lathe is trued up. On my lathe, on my Monarch, I have a 6-jaw set true chuck. And so I've already checked the run out on it using a dial indicator, and right now we're within maybe a half a 10,000th of being dead nuts on. Another thing that you want to do is make sure that your tailstock is aligned on the center line of the chuck, so that when you do any drilling operations, you'll be as close as possible to being dead on center. And of course, one of the techniques you use for doing that, and you're probably already aware of this if you're doing much machine work, is do a test bar. Take yourself a large piece of brass, take cuts on both ends, and then simply measure them. And you'll find out if you're out on one end, the end towards the tailstock, then you simply need to adjust your tailstock either in or out. But important thing to do before you start cutting. Well, let's begin. Okay, I've chucked up our driver center, and I've got it in the 6-jaw chuck, and our first operation is to make sure that this little plug is running true. We want to go ahead, take a few cuts down the length of it, and I've got a spacer that's going between the front face of the chuck to the front face of the driver's center. And so that way we're trying to keep everything reasonably concentric. If the outside diameter of your driver casting when you begin is reasonably circular as opposed to having some sort of distortions, then you can start this way. Otherwise, you might have to use some other techniques which we can discuss on another video. But the first thing we'll do, try to true up the plug. I'm using just a typical carbide insert. Nothing fancy here. Turning it about 500, 600 RPM. The size of the plug is maybe just a little bit under 7/8 of an inch. So we're going to come right up and touch it. This part isn't crucial in terms of the actual diameter of your plug. We just want to make sure that it's running true. So the first cut, just a real light cut. This would also be a good point after we make these cuts on the plug to go ahead and face the back edge of the driver center. You don't have to do it at this point, but you know, since you're already working on this side, you might as well. Let's take another 20 thousandths out of it, see where we are. Nice thing about a Monarch, one of these 10EEs, they weigh over 3,000 pounds, and so they're solid as a rock. Don't have problems with vibration. It's just a good, true running lathe. And they don't have to cost an arm and a leg. You can find one like this, which is World War II vintage, a couple $1,000, $3,000, something like that. You might have to do a little bit of maintenance on it, but these machines were meant to be rebuilt. Okay, let's see where we are out here on the face. So you can see I'll stop the spindle. We've got a nice smooth surface on the plug, and that's what we're going to flip around and put in the jaws. So let's make sure we get a nice smooth surface on the outside edge or the rear face of the driver's center. So you can see I've got a dial indicator on my carriage so I can see how far I'm going in. And we'll just use the same tool because we're not going to be taking a heavy cut, just a real light facing cut, and that's really all you need. Because remember, we're going to be machining the outside diameter of that as well. We'll just come back, take another pass, and then we'll go on over to the center. Okay, well, still got a little bit to take off there. The thing about this alloy, which is basically a white bronze, the machine's really nice. Easy to cut, and of course you can solder it if need be. Yeah. Okay. Next thing we're going to do is flip this around, and we're going to face the front side of the driver, and then we're also going to turn the outside diameter. So we'll go ahead and get rid of any chips. We're just going to come up and touch the outside diameter of the driver's center. Now, of course, depending upon what size tire, and that's what we're doing here, we'll be putting steel tires on these driver centers. You'll have to do your calculations for what size diameter you need on the center with respect if you're going to insulate the driver center or if you're going to just mount it directly on a press fit the steel tire. We'll be using some phenolic plastic insulation, and so we have to calculate that in, and then also assume we're going to have an interference fit in the whole kit and caboodle, about 1/1000th of an inch per inch of diameter of driver center rather. And so we need to figure that out, and then we're going to turn to that diameter. So we'll go ahead and take our first cut here. these tool posts where everything is, it's got a piston and it locks it in place, you can pretty much come reset it, put another tool on, and come back to the other one, and you'll be in the same place where all your numbers are on your hand wheels. Of course, the thing to have here would be a DRO, and there's one in the box. It's just not been put on. Digital readout. Okay. Of course, one of the things you want to be aware of when you're machining a driver center or doing the facing work, you don't want to crash into your counterweight if the counterweight extends beyond the crank pin hub. In that case, we have to set up over on the rotary table on the mill, do some mill work. But otherwise, we're just going to do some light work here. Actually, ideally, I'd like to be coming out with this rather than going in, but it might be a good idea to drill our axle hole. Okay, so just a light facing cut. In part two, we'll come along, we'll do our center drilling, and then reaming for our axle hole. We'll make sure that we've got the right thickness on the driver, and then I'll show you how to calculate for doing a press fit with a separate steel driver and phenolic insulation. Until then, this is Dave Queener, Cumberland Model Engineering. I'm glad you watched.